Good evening, everyone. This project, Dr. Phoebus is here. This is on rapid detection techniques for enumerating E. coli in wheat supply chain. And also, we kind of tried a different antimicrobial treatment to get rid of E. coli before the wheat enters into the mill. So why this flour safety is coming into picture now? You could ask me a question, Carly, we are whatever flour we receive, either we are going to bake a bread or make a cookie. So we are doing a heat treatment over there. So for sure, we are going to get rid of the E. coli or salmonella. But still, we are seeing the recalls and people are getting affected. The main reason is that people either eat raw cookie dough, so that which has some E. coli. And if there is any E. coli, it could stay up to 9 months in wheat flour. In the ambient storage conditions. So, and when me and Dr. Phoebus have interactions that we kind of meet, and whenever we have an interaction, the question we ask is it people now started identify or, they are checking the E. coli in the flour more, or is it because of consumer awareness? And the fact is both. So we are testing the flour for E. coli as well as the consumer is aware of that, fact that, hey, whether my flour has E. coli or salmonella. So there is one type of E. coli which is called a sugar toxin producing E. coli, and this could cause diarrhea, stomach cramps, and also the severe cases could lead to bloody diarrhea as well as hemolytic uremic syndrome. And in this, the E. coli O157, and also there is the non-O157 group, which are O121 and O26 are of interest because, can you go to the next slide? So if you see the recent recalls that have happened from the year 2017 till date, most of the recalls are related to E. coli O121 and O26. So that's what, those are the two organisms that we took interest and started checking, hey, can we develop a method to get rid of them? Also, can we develop a method to test them fastly? Because usually, if we want to test any product for E. coli, it would take up to 24 to 48 hours. Can you go to the next slide? And these are some of the recalls that are happening, and in 2019. So you could see many recalls have happened in 2019. And out of that, 13 out of 19 recalls involving wheat flours in 2019 are due to E. coli O121 and O26. So that's why those particular two organisms are of our concern as well as our interest. So, yeah. As there is no assurance, of consumers following adequate food safety practices, the production of safe wheat flours is important to minimize the foodborne illness. So as I told, if they make cookie or bread and if they eat it, it's totally fine. But if they eat raw cookie dough or if they consume the flour as such, then there is potential risk of food contamination. So with that reason, and as I told, it would take up to 24 to 48 hours to kind of check for E. coli and salmonella. So we want to develop a rapid detection technique. And Dr. Supriyan Das, can you go next slide? Thank you. Dr. Supriyan Das in the Industrial Manufacturing Systems Engineering is working with nanoscale material, and he's working with graphene. And this graphene, he's actually making them as a printable ink. And he came up with an idea saying that, hey, Carly, we could make some sensors which basically look as of blood glucose strips. And all we need to do is that, on that graphene sensor, we need to put an antibody for the E. coli and say, we could detect them in about 4 to 5 minutes. So whereas it is taking 24 to 48 hours versus 4 to 5 minutes. And in a wheat mill, we get tons and tons of material every day. So a particular wheat mill, they could mill up to 15 metric tons of wheat. And they can't sample from each batch and test it and wait for 48 hours to get the results hey, whether this has E. coli or not. So with this sensor, what we could do is we could test it in 4 to 5 minutes, and we could test more number of samples. That way, we can make sure that out of 15 metric tons of wheat, the particular batch that we are going to mill does not have the E. coli. So that's how we kind of started. So this is the method that we kind of followed. So first one is incubation of antibodies. So that's in the figure B, you could see the sensor strip that has the functionalized antibody for the E. coli O121, O26. And in Dr. Phoebus' lab, we we have Dr. Phoebus lab has basically have the E. coli 0121 that actually came from one of the national recalls that had happened in the US in 2019. So we kind of, Dr. Phoebus has that particular E. coli, and when we tested it, we could detect, these are the signals that shows that we could detect the E. coli 0121 in 400 seconds. So the sensor is showing us signals, if there is no E. coli, it would be a normal line. But when there is an E. coli and that 4 log E. coli, our sensor basically could detect it. So we could go up to 4 logs if any wheat has E. coli 0121, and if it is 4 log, we could detect it. And now we know that we could detect it up to 4 logs. Then we were having questions like, hey, Carly, all these mills are following some or the other treatment. Most of the mills, what they do is they either heat treat their flour to get rid of any pathogenic bacteria, either it could be E. coli or Salmonella. But when you heat treat your flour, what happens is that the baking quality is reduced. So we won't get a spongy bread. We won't get a good cookie with the heat treated flour. So that's one more thing. And the other thing is that when we are having the discussion, the major thing is that the cross contamination. In wheat flour mill, there is no other commodity. It's just wheat. So if there is any E. coli or Salmonella, whichever is entering into the mill, it's basically in the wheat. So if we can get rid of that particular thing in wheat itself, then we are not going to cross contaminate our sifters or our rollers or entire mill process basically. So with that idea, and when we kind of did some literature search, each method, whether it can be flour pasteurization, ozonation, or some kind of acidic treatment, each has its own advantage as well as disadvantage. So that's why we came up the concept of hurdle technology. Like, we combined acidic treatment plus heat treatment of wheat so that we want to exploit the advantages of both and ignore the disadvantages. So yeah, can you go to the next slide? Yeah. So the objective over here is that we want to develop that particular combination. So we use sodium bisulfate as well as lactic acid in the tempering water. And also we kind of heated the grain up to 55 degrees centigrade to get rid of close to 3 log reduction in the wheat. Yeah, and this is the process we basically followed. Next slide. So we kind of have a control treatment, which is the tempering step that the mills are usually following. So they kind of tempered the wheat kernel up to 16% moisture so that the bran would be broken as bigger chunks and the endosperm would get smoothened down. So we have that control treatment. We have just control treatment plus heat treatment. We have 5% lactic acid plus 5% lactic acid plus heat, 10% lactic acid, and as well as sodium bisulfate. So what we kind of observed was that with the hurdle technology combination that we were seeing, the 5% sodium bisulfate and 5% plus heat, as well as 5% lactic acid plus heat, we are able to get rid of close to 4 log E. coli reduction within 6 hours. So, and now the idea is that, hey, we are sure, we are gonna get rid of E. coli, but does this have any significant effect on the flour quality as well as baking quality? So we did our milling procedures, and our aim is, we don't want to see any differences between our control and our treatments. So, and also we want to keep our acidic concentration lower so that way there won't be any corrosion of the equipment. So we took that 5% lactic acid and plus heat combination as well as 5% sodium bisulfate and heat combination. What we did observe that there is no effect on milling quality, there is no effect on flour quality, there is no effect on the dough characterization. So that's what we wanted, So we kind of found a method now to get rid of the E. coli, which does not have any significant effect on the flour quality. All we have seen was there is a significant difference in the pH of the flour, but it's kind of very minimal. That's the only thing we have observed in this. And when we kind of did the baking project as well. And even with the baking project, when we did the bread, it does not have any effect. So the treatment does not have any effect on either the flour or the bread. Yeah. So basically, based on this study, now we could, with the sensor that Dr. Suprendas came up, we could detect up to 4 log of E. coli if the wheat has 4 log, then we could detect it. And with the hurdle technology combination that we developed, we could get rid of E. coli by even if it has 6 log, then it would come down and even we don't detect them. So we can get rid of that E. coli O121 or O26 basically. And this does not have any effect on the baking as well as flour quality. Yeah, and coming to the outputs, so one manuscript is accepted for publication in Journal of Food Processing and Preservation, and we kind of did 2 conference presentations. We had 4 graduate students, and 2 students are directly funded through this project, and 2 of them kind of supported the project. And we kind of trained 2 undergraduate researchers, one in graduating in milling science and one in baking science, who helped with the milling and baking experiments. And the Great Western Manufacturing Company, which actually makes the milling equipment, basically sieves, they we kind of recently entered into a non-disclosure agreement with them. They are interested in kind of taking this research forward. They have some ideas and we want to kind of help them out. And we kind of started a group called Flour Safety Research Group. And we have faculty from Grain Science, we have faculty from Food Science Institute, and we have faculty from Industrial Manufacturing Systems Engineering. And when we were having discussion, me, Dr. Phoebus, and the faculty from Industrial Manufacturing Systems Engineering, we could achieve the USDNE for grant last year for about $454,000. And what's next? So the idea is that now we know that wheat is having this E. coli and salmonella, but basically where it is coming from and how is it traveling in the supply chain. So with the faculty from IMSC department, we want to develop a big data framework saying that, hey, if your wheat is grown in this particular condition, or if your wheat is grown in this storage condition, then you may prone to have the E. coli or salmonella. So we are kind of developing a big data framework as part of that USDNE for grant. And Dr. Suprem Das, we could detect up to 4 logs. So he's planning to kind of we were planning to do some more experiments and submit a NSF or a USDNE for grant in the next year. And we were planning to extend, now we kind of got E. coli O121 and O26 knocked out. So we want to extend this to salmonella as well as the other E. coli cerebrobes. And we know that, the lab scale milling and lab scale baking worked out. So we want to use the Hall-Ross flour mill and see if the tempering combination that we develop, if it could be extended to pilot scale or not. And this, thanks to the GFS seed grant program, so 3 faculty from different departments, we came together and we were able to achieve the USDNE for grant as well. Thanks for this program. And this work would not have been possible with Jared Rivera, my master's student who is now continuing for PhD, and Daniel Vega working with Dr. Phoebus. He's now postdoc in the department, and Thiba Nagaraja working with Dr. Suprem Das, and Wenjun Ziang, one of the student of Dr. Suprem Das, who actually developed this sensor, and Shiv Prasad, one of my students, and Slater, Blake, and Fernanda, the undergraduate researchers, worked on this project. Thank you. I'm happy to take any questions.